Welcome everyone. Today, I will be exploring the essential principles of data engineering and how they contribute to building robust and scalable data systems. I'm Asibeh and I'm excited to share these insights with you. Data engineering is the backbone of any data-driven organization. It involves designing and building systems for collecting, storing, and analyzing data at scale. Let's dive into why this is so crucial. First, let's talk about data modeling and architecture. Data modeling helps us design logical and physical data models that represent data structures clearly. For instance, a star schema is a common model used in data warehouses. Choosing the right architecture, whether it be a data lake, data warehouse, or data mart, is crucial for meeting organizational needs. Next, we have data ingestion. Robust ETL or ALT processes are key for injecting data from various sources. It's important to decide when to use real-time processing, like with Apache, Kafka, versus batch processing based on your requirements. Scalability is another critical aspect. Designing systems that can scale horizontally is essential for handling increasing data volumes. Performance optimization should be an ongoing effort. Distributed databases such as Apache Cassandra are excellent examples of scalable systems. Maintaining high data quality is vital. Implement automated data validation and cleaning processes to ensure data accuracy. Continuous monitoring and alerting mechanisms help detect and resolve data quality issues promptly. Data governance and security cannot be overlooked. Implement robust access control mechanisms and ensure compliance with regulations like GDR. Tracking data lineage provides transparency about where data comes from and how it has been transformed. Effective data integration is crucial for a cohesive data ecosystem. Develop standardized APIs and ensure systems that are interoperable. For example, integrating various data sources using REST APIs ensures seamless data flow. Automation is key to efficiency. Using infrastructure as code tools like Terraform allows for automated infrastructure provisioning. Implementing automated testing frameworks ensures the reliability of data pipelines. Monitoring and logging are essential for maintaining systems health. Building observability into your data pipelines with comprehensive logging, monitoring, and tracing. Tools like Prometheus and Grafana help track the key performance indicators and set up alerts. Data transformation and enrichment make data more usable and valuable. Applying necessary transformations and integrating additional information, such as enriching customer data with demographics, enhances data quality. Effective collaboration and communication are vital for success. Maintain thorough documentation of data pipelines and foster teamwork using tools like Confluence and Jira for project management. Continuous improvement is essential. Establish feedback loops to learn and improve continuously. Stay updated with the latest technologies and methodologies. Regularly update your data pipelines based on user feedback. To conclude, we have covered the fundamental principles of data engineering. These principles are crucial for building robust and scalable data systems. I encourage you all to implement these principles in your own work. Thank you for your attention. Now, I would like to open a floor for any questions you might have. Right under this video. Thanks for watching today.